Not going over it.
We did, didn't we?
No.
We did on Friday.
Okay, so we're going to shift gears a little bit from congruencies and start to lead into similar triangles and similar figures. But first we have to talk about proportions. So because if figures are similar, like say from a dilation, right, makes figures similar, you know that all the corresponding sides are proportional, right? And what is a proportion again?
Proportion.
What's a proportion?
The ratios are equal to each other.
Right. It's two equal ratios. So don't just someone ask what a proportion is, please don't just say it's a ratio. It's not exactly that, right? Let's take a look at this example they have here. So it starts right here, okay? You're trying to mix water and juice powder, right? In a 2-to-3 ratio. So we have a ratio of 2 to 3. And we want to use 10 cups of water, okay? Because you have a lot of friends, whatever, swimming party, it doesn't matter. So we need to set up a proportion, right? So 2/3 is going to be the ratio we use for all our corresponding measurements, right? So let's see. It looks like it's water to juice powder, okay? So I like to, maybe use a letter or something. I'll use W for water, right? J for juice. Does that make sense? So if I look at this proportion here, it's hard to tell by looking at it, right? So maybe I'll just say, okay, top one is water, bottom one is juice, right? And so then if I write this, then everything across the top should be the water portion of it, and everything here should be the juice portion of it, okay? So this here is a proportion. The ratio should be equal, no matter if you're using 10 cups or 100 cups, right? We want equal ratio in the final product. And two equal ratios are called a
Proportion.
proportion. There we go. Somebody's listening, okay? So how do we solve one of these, guys? You've seen them before. Cross multiply, right? It's pretty simple. So we just end up 2x equals 3 times 10 equals 30, divide by 2. We get x equals 15, okay? But that's not exactly our answer, is it? It is. Okay? Oh, I'm sorry, that will be the answer. I was thinking of a different type of product. So that will be the answer, right? You'll need 15 cups of juice powder. Or is that what it is? It's in cups?
It's so hard.
You can't be talking about cross multiplying.
No, I'm talking
Okay.
thing.
All right. So we have these cross products. What is a product in math? You know what a sum is. What's a product?
The answer from multiplication.
Yes, it's the result of multiplying, right? So we have this little thing here, equality of cross products. And this is how we work with proportions, cross multiply. So if any two numbers, A and C, and some non-zero, whatever, two other numbers, B and D, right? If I have A over B equals C over D, then how do I get this here? AD equals BC. What do? Cross multiply, right? Okay? So let me give you a note, because this is actually going to give us another reason on some of our proofs when we get to, say, similar triangles and whatnot. So let's go to the notes page really quick. All right.
Page 65.
Flip over to it.
Thanks, sir.
So we need to talk about two terms, and we're talking about proportion and cross multiplying. And the terms are means and extremes.
Oh, come on, wrong page.
Oh, you're so silly.
That's your shit, Quirky.
Okay? If I have the following, A over B equals C over D. We have names for certain of these things here. Right? These two numbers here, whatever's in here, these are called the means of the proportion. Okay? And then these two numbers here are called the extremes of the proportion. Okay? And when we cross multiply, we're basically saying that the product of the means is equal to the product of the extremes, okay? So this is important to note. The product of the means equals the product of the extremes. Okay? So this will be something you want to remember, right? Because this will be a valuable reason in some proof you may do later on, okay? So when we do that, multiply these, we get AB equals, how did I set it up there? Equals, or AD, sorry. Set it up the other way. So AD equals BC. Okay? So the product of the means in a proportion equals the product of the extremes. Right? So these are the means here, kind of like the, I guess you call them like the inside ones, and these are the extremes. Right? Let's go back then. Let's work around with some of these. So here's some examples, okay? How can we tell if we have a proportion? Well, the ratios actually have to be equal, right? So how can you tell if you're given two ratios with an equal sign, it's actually true that they're equal? There's a couple different ways, right? So we want to know, is the ratio 3 to 4 equal to 7 to 9, right? Well, one way we could do this is to do what? What did they do? They cross multiply, right? And are these equal ratios? They are not. In fact, I would put a line through the equal sign, right? Because it's not equal, okay? So it's not a proportion. And by the way, the 3 and the 9 were what? The means or the extremes?
Means.
Huh? Those are the extremes, right? And these are the means. Okay? Over in part B, is the ratio 1.5 over 2 equal to 13.5 over 18? In other words, is it a proportion?
Yes.
And they found out by cross multiplying and got 27 does in fact equal 27. So yes, they are proportional. Right? How else could you do that, by the way? Is there another way you can think of? Like maybe with your calculator or something?
Divide 13.5 by 1.5 into 5.
Well, this is the division. Can I just do 1.5 divided by 2, get an answer? And then do 13.5 divided by 18, get an answer. And if they're the same, well, then what?
Okay, could you do
Proportional.
13.5 divided by 1.5 and then 18?
Well, why would you want to do that?
Because it was the same thing.
Yeah, right. So you could do that because really this is, if they are equal, both of these should be some multiple of both of those.
Yeah.
And you're thinking about, maybe you're not directly, but when we go to a dilation and there's a scale factor, right? So this might be 3 times bigger than that corresponding, and this might need to be 3 times bigger than that corresponding side. So that would work as well.
He's thinking right now.
That's right. Yep. Okay, so let's, look and see here. So what value of x would create the same, not the same proportion, they should say the same ratio, would create a proportion, which would be the same ratio, right? So what would we do here? Cross multiply and solve it for x, right? So 3x times 10, well, that's 30x, and 5 times 24 is 120, right? Divide by 30. If x equals 4, then we have a proportion, okay? And they check it down here, right? So it gets 12 over 24 equals 5, right? One way to check it also, you could either cross multiply, couldn't you? Could you put them both in the calculator, right? See if they're equal. Or you could simply just put them both in lowest terms fractions, couldn't you?
Yeah.
What's 12 over 24 in lowest terms?
1/2.
1/2. What's 5/10 in lowest terms? So that's another way, right? So that is proportional. Let's look at the other one here. Now, I don't know why they had that 5 in parentheses, but if we're going to cross multiply here, right, it's 5 times this entire thing. Here's the thing. when you have a fraction, a ratio, right, this horizontal fraction bar, which you're all going to be using, right, not the diagonal one, and here's like a good case to why the diagonal won't work, right? This, listen to me, I don't know why it takes me 500 million times to tell students this, but it always has. That horizontal fraction bar, yes, it does mean division, right? It's the operation division, but it is also a grouping symbol like parentheses, okay? So this is the equivalent of 5 times parentheses x plus 2, okay? The whole thing, which means when they don't need the 5 in. I don't know why they did that, okay? So it's 5 times the entire thing. And so then what do? What's that called? From algebra.
Oh, distribute.
Distribute through, right? Okay? Whatever. Okay? Then they go, I don't like how they do this, you go down, but whatever. So then you can just solve this, right? You get x equals 16, we'll make that a proportion. And then they check it, okay? So why don't you guys take a minute, take a look at A, B, and C here. And I want your algebra to be nice and vertical and neat, okay? And you circle your final answer to solve these each for the x's that are in them, okay? And be careful, like with these, that horizontal fraction bar is not only division, it's what?
Grouping.
Like parentheses, okay? So take a minute and do those. What is it?
X equals 18.
Yeah, I got it too.
How many got x equals 18?
How did we get it?
Well, what'd you do? 5 times x cross multiply.
No, I got the answer, but how did you get the answer?
Huh? 2? What's 6 times 15?
90.
90. Are you stuck here?
No, I did that.
Okay, so then you took algebra, right?
No,
What do you do to both sides?
it's out of my phone.
Okay. So x equals what?
How did you get X?
Don't.
You just dropped the 5 for some reason.
I didn't.
Randomly.
It looked at me.
Yeah. 18, you said?
I'm confused a little slightly on B and C. I need a little refresher on those.
It's like you stood up there.
Yeah, but like, I'm confused because of the fact that the X's are on the same like lines.
That's simple algebra.
They got that.
All right. X on both sides, you get them all on one side. What do we get for B? How many got 12? So we cross multiply, right? So 6 times x, so we do this, right? The whole thing equals 3x. Distribute through. Plus 36 equals 3x. Okay? So why did I use 36? It's harder than you think to talk and write. Same thing.
What's that mean?
6 times.
Minus.
Yeah.
Yeah. Minus that, yeah. Minus, right? So now I want all my x's on one side, right? So let's subtract 3x from both sides. Jeez.
Oh my God.
So we get 3x minus 36 equals 0, yeah? And now what? Not yet.
No,
Transfer.
Add 36 to both sides.
Do the transfer.
Sometimes kids get confused, man. If they got to subtract 3x from both sides and there's nothing, well, what's left? 0. Don't get all watered up there. Okay.
Yeah, let's do it.
How about C? 7. Do you have a question? About what part?
12.
Which part of it?
B, I got told that I didn't fall.
What did you do?
I don't know. The English technique built different.
And that's not even close, right?
She's the definition. Weird. Surprised they have this reference built different.
So if you do that, you get 3x. So what you have there, the x equals negative 12 minus x over 3. You got to divide those both by the way you did. Wait, don't start, like, you got to take care of the solving the addition and subtraction before you do any division. So
I also got
that first order of operation, yeah. You can add x to both sides. Whatever, you can do any of the equation you want as long as you do it to both sides. We got, what, 7 you said for C?
Yeah.
Yeah. So, 1 times 21, I'm not even gonna bother putting 1 parentheses times that, right? So wouldn't this just be 21 minus X equals 2X? Yeah. Actually, I like my X's on the left, so I'm gonna just, this bothers me. You don't have to do this, but.
Well, I thought it was beans.
Right, well, 2 things, does it matter? Equal signs are switchable, aren't they? Right? It is. Hey, if X equals 5, does 5 equal X? You can write them both.
Yeah.
Yeah, okay. So let's just do 2X equals 21 minus X, right? Can't do any dividing by 2 yet, right? You got
Yeah,
order of
yeah.
operation, right? We are undoing order of operation, right? So we have to start out by doing the adding of X to both sides. So we get 3X equals 21. Now we divide by 3, okay? Got it?
That's right.
Why do we, oh, because it's negative.
Yeah, you undo subtracting here by adding, yes.
I got that stuff.
Okay, let's look at some actual problems now. There's a couple different ways to look at these, right? And one will be like a total of things. So example 1, the ratio of boys to girls in the class is 4 to 3. So 4 boys to 3 girls, okay?
That's not a good ratio.
So there are 20 boys in the class. How many girls are there, right? Well, we'll set up a proportion. X will be the number of, or maybe we'll use G. I always like to use a variable that makes sense, right? So when I get done, especially if there's a lot of variables, I'll use G for girls, right?
Wow.
So if the ratio of boys to girls, and I would recommend starting out, right? Just put a colon there. It's not really, it shouldn't be equal like that. That's not quite correct. Colon. B over G, right? So now I know that boys go across the top, girls across the bottom here, right? So 4 over 3 needs to equal 20 over G, some number of girls. Well, let's see, right? Just cross multiply. 4G equals 60. Divide by 4, you get 15 girls in the class. Okay? Everybody follow that one?
You should tell them.
Can we, you guys don't mind there, Mr. Harrod, Mr. Harrod, if I take care of this? You can teach another class later? Okay. All right. Now let's look at when there's a total of things, okay? So there's a total, and there's a couple ways to do this.
I'm so confused about the first
Why?
one.
Ratio of boys to girls 4 to 3. So 4 over 3, 4 boys, 3 girls is going to have to equal the ratio of 20 boys to some number of girls.
So.
The ratios have to be equal.
20 divided by 4.
4 times G, 4G. 3 times 20, 60.
And if you divide that by 40,
Yes.
Yeah. Again, I'm not showing every algebraic step because you guys presumably passed algebra last year, right? So it should be old hat.
Should be.
Okay, now be careful. This one you got to be careful with. This is a total. How is this a total of things? Ratio of boys to girls is 1 to 3. There are 28 students in the class. Now they're not telling you that there's 28 girls, right? See how this one's a little different? They're giving you a total. Okay? So let me ask you a question. If we have the ratio of boys to girls as 1 to 3, okay, let's just take a class where there's just exactly 1 to 3. Like, if, say, for example, there was 1 boy and 3 girls. How many kids are in that class?
4.
4. So in the ratio of 1 to 3, there's a total of how many parts? 4, right? So we need to think of, for a total, they gave us a total, so I got to total this up. See what I'm doing here? So now that goes into your ratio. Okay? So now we're doing girls to total, right? Okay? So there would be 3 girls to a total of 4 in the lowest terms ratio, right? All together, you get it?
Yeah.
Okay? To some number of girls for a total of 28. So 28 now are no longer the simplest lowest terms class could be, right? 1 boy, 3 girls. Now it's total 28. So now we just cross multiply again, right? And we get, there are 21 girls in there, right? So there's another way to do this, okay? That's not necessarily with a proportion. And you probably saw this somewhere along the way, right? So remember, this 1 to 3 is a lowest terms ratio, right? Right? And in the actual classroom, the 1 and the 3 are some multiple. There's some multiple. So let's say there was 1 boy and 3 girls, right? But in an actual classroom, there's more boys and girls. But to stay 1 to 3, it'd be like, okay, that ratio 1 to 3 times, I don't know, 5. Does that make sense? Okay. There's some multiple that would go with each one of those that you multiply by. We don't know what that multiple is. Maybe it's a little like scale factor, if you want to think of it that way, right? So here's another way. Instead of setting up a proportion for a total of things, total means you add them up and they come to a sum, right? So it's not 1 boy plus 3 girls equals 28 students, right? It's 1 times some multiple plus 3 times some multiple will give you the 28. Does that make sense? What's that multiple? We don't know. What do we let stand for? I don't know in math. X. Or X, right? So do you see what we have here? 1x plus 3x gives us a total of 28 students. Okay, combine like terms. What's 1x plus 3x? Okay, so we're kind of back in the same boat, well, almost that we were over there, right? Okay, so now divide both sides by 4. We get x equals 7. Now be careful. X is just the multiple. Follow me? That's not the number of girls. Which one of these represents the number of girls?
3.
Okay, so once we get this multiple, that's not the answer, that's the multiple. So the girl part of the ratio is 3. We know the multiple is 7, so what do? And we get 21 girls again. You see how that works?
How many non-binary people are there?
Let's move along. Go to example 3.
Why'd you get 21 though?
3 times 7. Remember, 7's the multiple. Let me ask you this. How many boys would there be?
I think 7 boys and 21.
1 times 7. 7 boys. So this class has 7 boys, 21 girls. That gives us a total of 28. Right?
7 kids. 7 kids.
So look, so just to clarify, 7 boys and 21 girls is not the lowest terms ratio, right? So it's not a class of 1 boy and 3 girls. We multiplied the 1 boy and 3 girls each by 7.
Yeah.
Does that make sense? I like your Pythagorean triples, a 3, 4, 5. Double would be a 6, 8, 10. All the same multiple. Okay? Okay, example 3. Triangle, angles. The angles are in a ratio of 1 to 2 to 3. Okay? Now the measure of each angle. Well, okay, that'd be simple, right? One angle is 1 degree, the other is 2 degrees, the other is 3, right? So what does 1 plus 2 plus 3 equal? 6. You're saying that the angles of the triangle add to 6 degrees. I think you probably know better than that, right? Huh?
6x.
What are the angles of the triangle add up to?
180.
180.
What are the angles?
So the angle measures must be some multiple of 1 to 2 to 3. Right? And those should add up to 180. So it's not 1 plus 2 plus 3 equals 180. What would it be?
6x.
1 times the multiple plus 2 times the multiple plus 3 times the multiple is 180. Right there. See it? It's done.
Oh,
Yeah, but like.
180 and
So
divide
you
by
add up
6.
all the x's and it's 6.
Now we
Saying all
combine
the
like,
angles are equal though?
no, it said they're in a ratio of 1 to 2 to 3. So there's a smaller angle, right? And the next largest one is twice the size of the smaller one, wouldn't you agree? And the biggest one would be 3 times the smaller one, so not the 6, right?
And then you divide that 6 or 180 by 6.
Okay, so we get x equals 30. Well, now how did they get all the angle measures there? So 30 is the multiple, right?
because
Because you're multiplying the x's.
And you gotta get the 180.
So the smallest angle, 1. So that's 1 times our multiple of 30, which gives us 30 degrees, right? The middle angle is 2. 2 times our multiple that we apply to all of them, 30, gives us what? 60 degrees. And the other angle, 3 times our same multiple,
This 90.
90 degrees. That's how they get that.
So that'd be a right triangle.
It would be, yes, sir. Absolutely right. 30, 60, 90 right triangle. We're going to study the heck out of that particular
Is that
triangle
a
pretty soon.
perfect triangle?
No, not really. I don't know. Well, what would be fine for?
Perfect triangle.
I don't know. That's
Okay.
What?
Can you stop touching the drawings?
Quick look at number 4. I'm not too crazy. Whatever. So we have a quadrilateral with the sides in a ratio of 3:1 to 3:1, all 4 sides, right? So it looks like we have 2 shorter sides and 2 larger sides, right, in this thing. Are they all in the same ratio? Would these 2 sides be congruent to one another if we apply the same multiple? You're going to apply the same multiple to everything, right? And what about the other 2?
Yes.
No matter what you multiply them, as long as you multiply them all by the same multiple, right? 2 will be congruent to each other, the other 2 will be congruent to each other, right?
Yeah.
So what would this be?
Parallelogram or
Yeah, you're not even enough to tell you it's a rectangle, right? I would just say for sure it's a parallelogram because both pairs of sides are going to be congruent, no matter the multiple, okay? And anyway, let's take a look at these examples here. I'm going to have you guys go over these, okay? So read these, set up either a proportion or if it's a total of things, right? Be careful, okay? Number 2. Does number 2 look like a total of things?
Mhm.
Let's get in total.
No.
No.
Well, the 45 students is the
Oh, I know.
No, it's the, wait, the what now?
The 45 students, we're looking at 2.
This one here. Yeah. Oh, yeah. That, right. Okay. I would use, let's do it this way. 4 cups of water, right? Probably set it up like this. Water to powder. Like that.
I think I know that. Yep.
You see what I'm doing there? And now you know you won't get, like, if everybody look up here. If I do the water number over powder number, then accidentally over here do powder over water, I'm going to get it wrong. So I like to write that in there first, okay? So take a minute, see if we can work this one out. Forgot to record.
It's not like you're recording.
No, I just touched it. Yeah. Okay. Well, let's move on. Some of you already did number 3. What'd you get?
Well, I have that.
What?
Yeah,
30?
we were supposed to do 3.
Well, it's okay. Do it now. I'll give everybody a second.
It's 27.
Is 27.
25.
Yes, I can. Quiet. I'm going to show both ways. This is a total, is it not? This is a total of things. So, juniors 3, freshmen 2. What's the simplest case? There could be 3 juniors and 2 freshmen for a total of how
Oh,
many?
3 juniors? Oh, I
5.
You know, I didn't-
But it can't be a total of 5 because they gave us a total of how many? So this is our total number of students. This is juniors and freshmen added together, right? So let's do it one way, right? So these are going to get multiplied by some multiple. I don't know what it is. Let's call it x. So wouldn't we say that 3x plus 2x needs to equal the total of what? 45, right? We're finding the multiple. And then, right? So 5x equals 45. So what's our multiple? 9. Be careful. That's not our answer. That's the multiple, right? What do they want to know?
Juniors.
Okay, which of these is juniors?
3.
So the juniors would be 3 times our multiple,
27.
27 juniors.
I guess I was a little bit.
Okay.
That was just a bit off.
I was so,
Well-
I'm still confused.
Well, let's look at the other way to do it.
I was gonna say I got half a person. That's
So we have a total of things, right? Let's say it was the simplest case where there's 3 juniors and 2 freshmen. What would be the total of things then in the room? 3 total. Yeah. Guys, if you got 3 juniors in a room along with 2 freshmen, how many are in the room total?
5.
In the simplest case, right? But this is not the simplest case because we know the total's not 5. What is it?
45.
45. So there's some multiple of 3 and 2 that gets us to 45, right? So what would be the equation if we did it the other way? 3 juniors times some multiple plus 2 freshmen times some multiple gives us a total of what? Oh, I did was the same way. Never mind. I'm doing it the same way.
Oh, silly.
So silly.
Hang on.
You should do a 5 first.
What's 3 plus 2?
5. I think.
So now give me a proportion. How about juniors to freshmen? Or junior not to freshman, but what? J
Coaches.
to total. So J would be what? 3, right? Over a total of what? 5 needs to equal. Okay, on the other side, they gave us a total of 45. Where does that go? Right bottom. And what goes above it? Well, we can use it. Let's use a J for juniors. What? Yeah, right. That's what. Yeah, it does, right? But know how to do either way, because there's some cases where really the only way to set it up will be like this, and this one will be awkward. Sometimes vice versa. You got to know both ways, right? So we just cross multiply, right? We get 5J equals what? What's 3 times 45? 135. Divide by 5. 27 juniors. Okay? So remember, when you're setting it up this way, you're just finding first the multiple, right? Which is what you multiplied the 3 to 2 by to get your answers, okay?
I like the first one better.
We'll know both, because sometimes one will be more useful than the other.
I did the second way the first time I got it wrong.
All right, let's try number 4. Read that over. Is this a total of things here?
Yes.
You know that because it's triangle angles, and you know they. Oh, stretch it, not angles. We're not talking about angles. We're talking about sides and. So the perimeter is the total of sides, isn't it? Okay. Read it over. So I'm done, right? Not done. That's just the multiple. Which one do they want? The shortest side. Which one of these is the shortest? 3, right? So it'd be 3 times 3.5 is 10.5 centimeters. Who did it the other way? Who did it the other way? What'd you do? Give me what you had.
I had 3/18.
Well, so let me do the short over total. How about that? Or perimeter, right?
I had 3/18. X over 63.
Where did the 18 come from?
Oh, it's the total up.
So in that ratio is a total of 18 parts, right? Okay, good. Equals, I'm sorry, what over what?
X over 63.
Yeah. Right? Everybody see how she did it? 3 over a total of 18 equals our short, right? Short X over total 63. So we got 18X equals what? What's 3 times 63? You're the one that did it. You didn't even tell me?
129.
Huh?
189.
Right? Is that what you got?
Yeah.
Okay. Who was saying it? So we divide, we get 10.5 centimeters again. All right, get the hang of that then?
Yep.
Okay, so we have just one Regis question here to look at. And you see where they say the ratio of similarity here? Ratio of similarity?
Yes.
Say like by means of a dilation, perhaps? What's another name that we could use for ratio of similarity that we've used quite a bit in here? The ratio of similarity. What do you think?
Division. Multiplication.
Scale factor?
Let's say it like that.
Because felt like it. Scale factor, right? Two things are similar. They come from probably a dilation, right? And dilations have a scale factor. All right, so read that over. Let's set something. So we'll set this up here real quick.
Are you thinking?
Boys to girls. Let's just do, and you could go do girls over boys, right? As long as you do the same thing all the way around, right? So I'm going to do B over G, just to keep my brain straight, okay? So 1 to 2. So 1 over 2 equals something over something. What over what?
3 plus x over 3x minus
X plus 3 over 3x minus 1. Remember, these horizontal fraction bars that you all use now, not the diagonal, goofy, stupid ones, are also grouping symbols, right? So let's cross multiply. So 1 time, I don't need 1 time, so I can just do 3x minus 1 equals 2 times the whole thing, right? 3x minus 1 is 2x plus 6. So let's subtract 2x from both sides. How about the same time we add 1 to both sides? You guys can do that now, right? We don't have to show every little baby step, do we? Am I going to lose anybody if I do
Oh,
this?
yeah, definitely. So going one step at a time.
Right? I subtracted 2x from both sides. At the same time, I added 1 to both sides.
That's exactly right.
Okay. But look at here. That's not the answer, though, right? But look up here. Oh. Not quite. What do we have to do?
3x.
So GR, we got to plug it into this guy, don't we? 3 times 7 minus 1. So it's 21 minus 1, which is 20. Okay? Any questions on this one? All right, so you got to do this work here, right? That's the work you got to do. So